thank you for the introduction. I think I have to start with, where does virtual reality stand? We're not there that we can substitute a complete course and hold a complete course in VR. I see it more like a field trip to a museum that you do once or twice in a course. And that's what I do. Once or twice, I have a VR experience. And as a museum trip, it's very exciting for the student, and it also needs some preparation. And I'm trying to help you with that. So the goal of the presentation is to support instructors who plan to use VR in their courses with buying headsets, student preparations, deciding if it's in classroom, in a VR lab, or online teaching. And if you have any questions and I can help, here's a link that you can use later on. It's also on the bottom of the slides. And we can set up a private meeting and I can answer all your questions that might come up later. I also have 2 VR demos prepared, and they are technology-based, very different. One is cloud-based. It runs in Horizon worlds. That's what Mark Zuckerberg calls his metaverse. And the other one runs standalone inside the headset. So we start with the first one. And I said already it's cloud-based. And the nice thing about that one, it supports out-of-the-box multiplayer. It's part of the Horizon world, so it's called a world rather than an app, but that's pretty much the same. What is also good, it is accessible. So students who can't use the headset can use the app in a browser. So let's go forward. The app or the world is about a real estate data set. So students enter a lecture hall type of setting, and they will work with a regression. So they will use quality, which is in units from 1 to 20, the quality of a house, to predict the housing price. This is what the instructor in the lecture type setting demonstrates to them. Afterwards, students go to breakout rooms, and a maximum of 4 students can go to each breakout room. After then, a new breakout room is automatically opened so they can work in small teams on a similar problem. Now it's how square footage is related to price. They have the formula, they have the diagram. I want to show you the experience if there are students around. So I took a video with 2 volunteer students, and I will just play it now and just comment on it. So I make it full screen. So the students go to Horizon World. That's where many, many apps reside. And then they find the simple regression app. And I clicked it already. It's starting here. And you see it. There are other apps for McDonald's, Spin the Bottle. Here is my app or my world. I click on it and it starts inside the browser. It would be 3D. Here it's obviously only 2D. We enter the lecture hall, or I, as an instructor, enter the lecture hall. Here are my students. Hello, students. Yeah, they wave back. That's nice. And then here on the ground, you see 2 panels, a green and a red panel, and I can use them by stepping on it to change the regression line. But first, I would explain to the students the axis, the quality axis, the mean of the quality axis, the mean of the price axis, and I would explain to them that the regression line always goes through these 2 means, so it turns through that points. And now I step on the green and the red areas and I can change the regression line. After I have explained that, and obviously I explain it in a little bit more detail than now, I ask the students to follow me into the next room, and that is the room. I say, hello, students, follow me. So we go to the door. I wait for them at the door. And the students follow me here. They go through the door. And in the door, there is a teleporting device where they can go to another room. I will follow them so you can see what they are doing. So the first student will enter the next world, which is a breakout room, by just simply walking through that teleporting device. Student disappeared. Second student walks there, and I will follow them, what I usually don't do, but you should be able to see what I would see in my headset when I play the game. And this can be played in the classroom. It can be played online. We can fully communicate in that game through our headset. So I'm going to, and what you will see is the breakout room where students work on an assignment. Here we are, and you see they are busy changing the regression line, watching the formula. Here is the assignment, what they have to do. And there is a timer. They have about 9 minutes left. After 9 minutes, there is alarm sounding, and they go back to the lecture hall where we do a debriefing. And you see here is the entrance to the group room, and I stop the experience here, and we simply go to the next slide. Okay, what I also want to show you, I talked about the browser view. Students who don't have a headset can use it, but also if you don't have a headset and your students have a headset, as a second best solution, not 3D, you can go to that browser-based app, and it's exactly the same app. It opens here like exactly the same way. In the browser, it's fully interactive, and we can see each other. You will not see anybody here because there are no students right now. See, I can walk here. I can turn around. I can look at the formula. I can walk forward, and I can adjust the regression line here. I think you got the idea. So let's go back to the presentation. So what if you want to start with VR? I just want to share a few experiences that I had with you. So most of these experiences were based on mistakes I made. So I don't want you to make the same mistake. So it starts with which headset you should buy. The market leaders are Apple, very advanced, but very expensive. And they don't have as many games at this point. The new kid at the block, and it's really new because it came out a few days before today, is the Galaxy XR that will open a whole new world. But that will take time, and I love to discuss this a little bit more when we have the discussion. But currently it's $1,800, so we hope price comes down, or maybe they have a cheaper version. What I'm using is a MetaQuest headset. It's between $300 for 128 gigabyte memory, and 512 gigabyte cost you $499. This is what everything I'm showing you is based on, and I believe currently that's the right solution. And let's see how much that costs. I would suggest to go with between 8 and 16 VR headsets plus an instructor headset. Why 16? You have a lot of students in your classroom, and they're jumping around and they're exploring things. So to manage 16 students live in your headset is not easy. And it's probably a good idea to have a teaching assistant around if you can. Otherwise, you have to do it somehow, who can help the students with setting up their headsets and so on. You can also go with a lower set of headsets and double your capacity, and I think that's a good idea. I tried that before. You just show your experience in 2 batches. Half of the students come on time to your class, half of your students come in the middle of the class, and you present in 2 batches. That extends your capacity from 8 to 16 and from 16 to 32. So the total cost is, and I would actually suggest go with the lowest level, 8 headsets plus 1 instructor headset, 128. That runs 2,600 to 4,000 if you use a higher end one, but I think the lower end one is sufficient. And if you run 16 headsets, then the cost range increases from 5,000 to 8,500. I think you get an idea. Again, I think to start with, this one is just fine. And you can even start with 5 student headset. And then if you have batches, maybe you do 3 batches in your class and you still get it up to 15 students. So this is important. How do you prepare your students? Ask them for pre-existing conditions. That is super important. Also, inform students about possible vertigo. In my experience, it's not a big problem, but from time to time you have a student who experience vertigo, and they should get out of the headset as early as possible, because if they hang in there too long, it might later on take like 15 to 20 minutes until they don't feel dizzy again. The browser version, as shown, shows a good alternative, so students who don't want to participate with a headset can still participate with a browser. I suggest strongly deliver your experience in a sitting mode. You can do it in a standing mode. It's actually more exciting, but there is a danger that students bump into each other and that they bump into furniture. So I think you don't want that. You should, and that's not that obvious, run your headset in tunnel mode. That is, you can set it up that when students move, the peripheral view goes away. You look like a little bit like through a tunnel, and that really helps with vertigo, and it is not that distracting as you think. I always do that. And then these 2 topics are important. Introduce your students to the controllers of the headset. Explain to them how they move around, how they can select items, explain how to enter the world and to start the app. And I would budget about 10 to 15 minutes of class time to doing so you can really do it thoroughly. What are the venues? Cloud-based Horizon World requires a lot of Wi-Fi bandwidth. So if you're lucky enough, your university provides a VR lab. That means it's basically a lab that has a higher bandwidth. If they don't, our university doesn't do it, you can work in a normal classroom. I work with about 8 students at the same time. You have to experiment a little bit, because if you strain the bandwidth too much, students would move out and in of the apps and you don't want it. Another workaround is students, instead of using the Wi-Fi from the university, if they have, they use their own cell phone Wi-Fi hotspot, and that's totally sufficient. I tried it with a throttled one, and that takes capacity away that you don't need from your Wi-Fi from the university. What I also did, I sent some students together with the TA to another story, so they have another Wi-Fi access point. And because we can communicate through the apps, that makes actually no difference in types of performance. And then obviously you can also use your Wi-Fi experience online. Then every student is on their own network. That is totally sufficient, works like a charm. Another alternative, and that brings us to our second app, is you use a standalone app. The standalone app runs inside each VR headset. App loading is required once, so you have to install it either from the Meta Store or from SideQuest. We use SideQuest and we explain how it is done. The bandwidth needed is very, very low, or sometimes you don't need any, depending, but there is no out-of-the-box support for multiplier mode. Still, the app I will show you have some interaction. The instructor actually can decide what students see. And when it comes to accessibility, the instructor can share his or her screen, and then students will see whatever the instructor sees. The diagram app has a collection of data sets. They can be preloaded, and each data set collection, which consists out of a few data sets, can be chosen by the instructor with a code. And there is always an instructor code for a data set collection, which is the even number, and there is an odd number for students. And here are a few ones that are already preloaded. Multivariate regression, you will see that in the demo. Another one with multicollinearity, I'm working on it currently. We have a random forest and AI app available. And we have an app that shows the degree of freedom in regression in a 3D setting. Last but not least, you can upload your own one. If you're interested, let me know. I will help you with it. You get your own code. I make it public or I don't make it public, whatever you prefer. Just contact me. And we will work with a multi-regression app. This is again about a real estate data set. It's again a regression. It's square footage on the first axis, condition on the second axis. These axes are on the ground, and price is on the vertical axis on a cube where the data are shown in 3D. So let me try this. This is what the instructor sees. I put on my headset and I start the app here, ECVR. It starts. I programmed it with Unity. And I and also the students, they would have a similar view, but not simultaneous. They can move independent, but they can't see me. I can't see them. I log in. I log in with the instructor code here, 590002. That means I can advance the data sets and the students see it. So this is what the students see. I would suggest to the students, walk a little bit inside the diagram. And if you see data points in 3D, it's such a different experience than see it in 2D. I mean, what we try in class, we have a 3D view and we put it on paper. That makes it 2D and it's very difficult for students to use. Students would explore a little bit the axis, square footage, the axis, the vertical axis. I let them do that about 5 to 10 minutes, just play around a little bit. And then I would tell them, hello, students, I will teleport you to this red pedestal here. And when I push the button, all the students will move and get the same view than I get. I push it, and you see the data points are moved into a 2D view now because the condition of the houses are artificially set to 0. Everything else with the data point is the same. Student can adjust the regression line here, the formula changes, and the coefficient is about 200. Then I would tell students, okay, we are going now to the blue pedestal, and then we see the blue axis. And I beam them there, or I teleport them there. They can see it, and they can do the same thing. They adjust the coefficient so it fits well to the data. And try to remember it's about 20,000, 17,000 in that ballpark. These data are uncorrelated, so you can actually adjust them one by one. I tell the students again, now we go to the 3D view. And here's a regression plane. And now the students can do exactly the same. They can collapse on their controller, they can collapse the data to the average, so it becomes 2D. They adjust the plane again. And it's again about 20,000, 18,000. So now then they can push the button, it becomes 3D again. They see it's not a perfect adjustment because the square footage coefficient is not adjusted. So they can go here and they can adjust the square footage one. First, they collapse. Probably they can just adjust it as they want, but it's a little bit easier if they get the data again to a 2D view. They adjust it. They get out of the 2D view. And then I would suggest the student, now look at the formula. It's the same. Theoretically, it would be exactly the same, but we just did it kind of quickly. It's the same formula because the data are uncorrelated than what you got when you did it piece by piece. And students can walk into the plane and they can see how well the plane adjusts. And if you talk about the prediction arrow, it's so much easier to see because it's basically the distance of the points from the plane. So that's what I wanted to show you here. Go back to the presentation. And here's a full-length video if you want to see that. Here's a trailer. And I want to answer your questions. So we are ready for the discussion now.